Hi, Alex. Thanks so much for joining me today. I really appreciate it.
Of course. Thanks for having me on.
Can you start by describing your role at Aqua America and talk about the type of analytical work your team focuses on?
Yeah, of course. So I'm an organic chemist, which means I primarily run our organic chemistry methods here. They include mainly like taste and odor products, disinfection byproducts, volatile organic compounds, and of course, PFAS. We mainly use GCMS and LCMS instrumentation to analyze for these compounds, and we'll also do regular maintenance on these instruments just to make sure they keep running smoothly for us.
I have to say that you have one of the nicest labs I've visited with some of the most friendly people. It really stuck out in terms of just how well run everything was. Is the facility relatively new? Because it seemed brand new when I was there a few years ago.
Yeah, so you're not far off with brand new. It was about 2 years old when I started, and that was almost 4 years ago. So right now it's 5, 6 years old. It's very new, very fancy. We get a lot of requests for tours of people that just want to like see the lab and all the fancy instruments. We're very proud of it.
Absolutely. I believe I stopped by after a PitCon that was in
Mhm.
Philadelphia. So I was nice and close by. For listeners who might not be familiar, what does it mean to be a regulated drinking water lab? And what agencies or guidelines govern your testing practices?
So being a regulated drinking water lab mainly means that we put out data that complies with all the EPA or other regular regulations that are required for our systems to maintain certification to keep giving out water to the public. We mainly deal with the EPA and the PADEP as far as regulatory bodies go, but we also have certifications in other states, which requires us to adhere to their requirements as well.
Yeah, I was curious about some of those key criteria or like what does compliance in a general sense look like for drinking water analysis, let's say?
Well, it looks like a lot of QC. At the end of the day, most of our methods in a batch, we're limited to 20 samples and 8 or 9 additional samples will be added on as QC. So we'll have calibration checks, quality control check to make sure our analytes, even from different vendors, are recovering at good levels. We'll have spike matrix checks. So we'll actually have a operational sample collected and we'll spike that with the analytes we're looking for to make sure that any anything else in the sample that we're not looking for isn't interfering with our measurement of the analytes. We use mainly internal standard technique to quantify the samples to make sure we know how much is in there. So we have to make sure that that's recovering well. We use a surrogate to make sure that the quantification from the internal standard is consistent and accurate. So yeah, it's a lot of QC.
Yeah, that's totally understandable. Are there any common misconceptions about regulated water testing that you'd like to clarify?
Sure, yeah. I say the biggest one we get is the time it takes to put out the results for these samples. We'll get samples from operations or from outside clients and they'd be like, where's our results? And it's like 3 hours after they brought the sample and we're like, whoa, hold on. Most of our methods will require at least a full workday to get even a preliminary result out. And that's, due to, on one hand, the QC that we have to run. Like I mentioned, there's like 9 separate samples that need to be run just for QC purposes before we even get to the field samples. Or a lot of our methods like PFAS or for haloacetic acids, disinfection byproduct, they have long extraction times. So we have to extract these samples and then prepare them, and then we can get to that analysis part. So it can be pretty lengthy in order to even get that preliminary unvalidated result to our clients. So we want to make sure all that's done. And then if it's compliance, right, we have to peer review all those results. They have to go through the supervisor to be validated. And then that has to go through our quality assurance department after that to make sure everything's in order. So it takes a lot for us to get results out in the first place.
I'm not sure what those people are imagining. Maybe they're picturing you taking like the pH level and it's just like a 2-second answer.
Or one of those one of those field GCM methods, you just pop the sample in and read a number. It's like, we unfortunately, the EPA does not like anyone doing that for regulated.
That would be real easy, but
it would, but then I'd be out of a job.
Yeah. Well, I always, on my end, it's more the battle of direct injection. Well, in some ways, you just noted that, right? Because we focus so much on analyte concentration, and certainly it would be easier if everything was just direct injection, or the topic of eliminating all sample prep.
Yeah, and that's another misconception is people assume we can change the method and adopt new technologies as soon as they come out to make things more efficient. It's like, no, these methods are very specifically worded on what we're allowed to use and how we're allowed to. Even if there is things we're allowed to modify, it's very specific things that we're allowed to alter. And even then we have to have explanations for why we're doing the things we're doing. So, well, it's nice they come out with all this nice, fancy new stuff. A lot of times we can't even use it. It's like we have to stick to our methods, and that's going to be what it is.
And for better or worse, those methods can evolve really slowly over time. I'm sure some of the processes you've been doing have been completely unchanged during your time at Aqua.
Oh, absolutely. These methods a lot of them have been unchanged for a number of years. So like a lot of times there'll be technology out there which will completely eliminate, right, like an extraction process. But because it hasn't had the time to go through all those tests with the EPA and the states to become approved by those, we can't use it for compliance.
Personally, it's always interesting where I see both sides of it, in the sense of I visit a great lab like yours, and I know to each step of each test what is being done, because I can just reference, what's 533, 537.1. Whereas when I visit a academic research lab, they're starting with that method in terms of their PFAS work, looking at PFAS levels in fish in Lake Michigan or something. And they're starting with 1633, and then it's how do they modify that for their needs. So it's just interesting, both sides of it.
It is, definitely.
One thing I'm not too familiar with is how taste and odor is really analyzed. So I was hoping you could share an example of how your team investigates that analytically.
Yeah, of course. Taste and odor is a big part of what we do. Being a private company, we answer to our customers, right? One of our main methods is a standard method for MIB and geosmin, two taste and odor chemicals. They're kind of earthy, musty smelling, tasting. Geosmin in particular is what you'll find in beets, and that beet earthy flavor comes from the geosmin chemical. They often come up after rain. They're an algae byproduct. These chemicals aren't harmful in any way, so there's no real danger with them, but a lot of our customers will find it unpleasant to find it in their water. But there are situations where we're not really sure what the taste note is coming from. We can't find MIB and geosmin in there. It's something else entirely. In that case, we can run a sample of the water on our GCMS under a broad scan method. So we'll see every peak in there, every compound that is in that sample. And then we'll use a library from NIST or other research body to just manually identify those compounds, just qualitatively. So we'll be able to see what chemicals are in there that could be causing this like strange taste, odor. And then we'll also do pretty regularly, we have taste and odor panels. So we'll have customers submit that might be a little fishy to them, like what's going on here? And then we have a method where the analysts actually smell and taste the water and try to come up with a working hypothesis of what's going on in there. Is this something urgent? Is this just, they're very sensitive to chlorine or something?
That was going to be my follow-up question, because I could certainly, in my head, picture a scenario where the team is huddled up and you're almost placing bets on what you think it might be just based on experience. I don't know if you have any anecdotes about that. Have you ever thought, oh, I think it's this, and it ended up being right on?
Not a ton of that, just because they tend to be pretty preliminary tests or outside clients. Like, we're not sure what's going on here. We tried a treatment thing, but now it tastes like something else entirely. But we do have some wild samples that we get in from all over the place. Like, this one smells a little gasoline. What's going on with that? But it's definitely an interesting process.
Well, I'm sure you take a lot of pride in the importance of your work and how critical it is to all of our lives. It's certainly at the top of the list in terms of quality of life, I would say.
Absolutely. It's an extremely important thing to be involved in, because it's like central point of the human survival of water, right? So we want to make sure that everybody has access to that clean, safe water that doesn't taste like MIB and geosmin too,
Totally. I may have mentioned a few of them by name a moment ago, but I was hoping you could discuss what methods the lab uses for PFAS detection. And yeah, obviously, your lab has a significant focus on safe drinking water.
Absolutely. Yeah. Mainly right now we're using 537.1 for all of our compliance needs. A few years ago, we transferred to that from 537 to get those extra compounds in there. We're currently working on getting certified for method 533, which will expand our compound list even more. But mainly right now it's 537.1. It's all of our compliance. It's a 3-part process. We extract the samples. We have to blow it down on the hot water nitrogen bath. And then we have to reconstitute and run the sample on our LCMS.
Yeah, and that's certainly why I was lucky enough to visit your lab previously as a customer of Work Animation. I was hoping you could describe why that blowdown step is important for the precision at those trace levels.
Absolutely. That's the reason we're able to get down that low in the first place. After extraction, we have the sample in a 15 mil tube. It's got like 7 mils of methanol in there. And we put it in that hot water bath, heated to like 60, 65 degrees Celsius, have nitrogen blowing on it. We evaporate all of that methanol. It's completely dry. After that, we're able to reconstitute it. We make it about 1 mil of exactly 1 mil of methanol and internal standard so that we can put that on the instrument. The reason that works is because these PFAS compounds are big molecules. They won't evaporate under these conditions, but they will stay at the bottom of that tube where all of that methanol will go right out. And that water bath enables us to do that quickly and efficiently, which is super important in a process that's as long as PFAS is.
Yeah, I'm happy to hear that. What upcoming technologies do you expect to really impact your work? Certainly, you're somewhat constrained by the regulated methods, but just in a broad sense, I was curious if there was anything out there that's exciting to you in terms of improving this type of work moving forward.
Yeah. Well, like we've been talking about, PFAS is a big focus now. We're constantly getting new updates from research about what chemicals are included in PFAS and that we need to test for. And it's a topic of debate within the government of how they should regulate it. So we want to keep ahead of that curve and be able to accommodate any new regulations that come out, whether it be at the federal level or at the state level. As far as technology, there's always that push for lower and lower levels, being able to see increasingly trace amounts of these contaminants. Eventually, the idea is we can see so low and keep our monitoring of these compounds really accurate at these trace amounts so that we can really ensure our community safety and the quality of our drinking water.
And I know your lab has always had a focus on efficiency in the process. For example, moving from standard SPE to, I know you have those nice automated chromachrome models. So always that continuous improvement and trying to do things as effectively as possible, but trying to deliver the best answers as quickly as possible.
Absolutely. We have thousands of samples that we have to get out every year to the regulatory bodies for outside clients, just for operations. So anything we can do to make that process faster, more efficient, to give them the results they need at that level of quality that makes the data reliable, we really try to keep up with.
Well, this has been great, Alex. I really appreciate the time today, and thanks for talking to us about your PFAS work.
Of course, it's a pleasure.